Hello everyone, welcome to this video. In this video, we shall be learning about a result, or you can say steps by which we can very easily prove isomorphism of groups, right? So let's understand this thing here. So in order to prove that the given group G is isomorphic to another group G bar, we should follow these steps. So the first step is we have to find a mapping or a function, say phi, which maps all the elements of G to all the elements of the group G bar, right? So this should be there for isomorphism first step. Now once we have a mapping phi, next the mapping phi should be 1 to 1. So that means how will you prove that a given mapping phi is 1 to 1? For that, we will assume that phi of A is equal to phi of B. That means the image of two elements here, they are equal to each other. So we will prove that their pre-image, right? So A is also equal to B here. For A, phi of A equal to phi of B, we also have A equal to B here, right? Next thing we will be, so this proving this thing, it will prove that for different elements A, B here in the domain G, we have different elements in the range, right, which is G bar. Third step is proving the onto property. So we will prove that the defined mapping phi is onto. So what does it mean and how will we prove that it is onto? So we need to show that for every element, say G, small g bar present in capital G bar, right, we will have some element G. We will find an element G in capital G such that when you apply phi onto this small g, you will have small g bar, right? So this thing should be there. These are the normal properties that we were proving from the very starting of mathematics, right? So we know how to prove a function is 1, we know how to prove function is onto. The new property that comes here is property 4, which is the operation preserving property. Now what does this property tell us? Here we wanted to prove that the function phi is operation preserving. It means that we will prove that phi of AB is equal to phi of A into phi of B if both the group operations in G as well as in G bar, they are multiplication. So here also we have multiplication of A and B, here also we have multiplication of phi of A with phi of B, right? Now notice that in step 4, in the left hand side, what we are doing, we are first of all multiplying or combining the elements by the group operation in G, and then we are applying the mapping onto it. And on the right hand side, what we are doing, we are applying the mapping first on the element A and to the element B, and then we are combining them both, right? So this is what we are doing. So what all ways are there if we have different group operations? If we have different group operations in G and the group G bar, so let's see what are these. So while combining the elements in step 4, the operations, they should be kept in mind. Why? Because suppose I am giving you an example. Suppose we are having an operation of multiplication and an operation of addition. So in how many different ways can we do that? So let's see. If the group operation of the group G is multiplication and the group operation of the group G bar is addition, then the operation property preserving property would become phi of the element A with element B. They are combined by the group operation of G, which is multiplication. So we are multiplying both the elements. Next, what we are doing, we are writing phi of A and phi of B. Now here we have to apply the operation of G bar, which is plus, right? So we are adding phi of A and phi of B. So this is the first operation preserving property when the operation of G is multiplication and G bar is addition. Similarly, when we have both the operation as multiplication, so that is quite simple. Phi of AB is equal to phi of A into phi of B, right? For the third one, when we have addition and multiplication for g bar. So when we have addition, we have a plus b here, and then we are applying phi onto it. And when we have multiplication in g bar, it is this multiplication here, phi of a with phi of b. Similarly for the last one, when both of them are addition, so in that case, we, for the elements a and b present in G, we will apply the addition operation and then apply phi onto it. And for the elements in the right hand side, we firstly apply phi onto them and then we add them, right? So this is as simple as that. But you should not confuse for different group operations in different cases, and should keep all of these things in mind. Well, that is it for this video. Thank you for watching.